Right, good morning, everyone. And today we'll be having a short discussion on partial differentiation. And my reference here is the book of John Bird, 7th edition, Higher Engineering Mathematics. And today we will be having just a short discussion and one example problem in partial differentiation. Okay. Partial differentiation is when we differentiate a function having two variables. And in these two variables, one variable is kept constant, and the other differential coefficient of the other variable is found with respect to that variable. Now, the differential coefficient obtained is called a partial derivative of the function, right? And in this partial derivative, a curly d is used to denote a differential coefficient in an expression containing more than one variable. So we take the partial derivative by keeping one variable constant in a function having two or more than one variable. So let's have an example. Right? Suppose we have z of certain function which equals to 5x to the fourth power plus 2x cubed y squared minus 3y, and we're tasked to find, we have a here and b. Our letter a here, we have the partial derivative of z with respect to x and the partial derivative of z with respect to y. First, in this problem, we are taking the partial derivative of the function z with respect to x, meaning to say all variables other than x will be kept as constant. Okay, to find the partial derivative of z with respect to x, we will let, if we can see in the original function, we have two variables here. We have x and y. Meaning to say, since we are taking the partial derivative of z with respect to x, the y variable here in the function will be kept as constant. Now, z is equal to 5x to the fourth power plus 2y squared x cubed minus 3y. Take note that this term from this original function, we do manipulation here for we are going to treat y here as a constant. 2 here is a constant, and in the partial differentiation, we let the other variable, not the differential coefficient, as constant, right? That is why we moved here y squared beside 2 because this will be now kept as constant, okay? And we have here minus 3y. Here in the function, we will now take the derivative of the function in terms of x or with respect to x, right? The partial derivative of z with respect to x, we have here, since this is x a variable, we are going to take the derivative. We're going to take the derivative of this function, 5x to the fourth power. And then we have plus, this is a constant, and this is in x. That is why we are going to take the derivative of this term. And we have here minus 3y and then the derivative of 1. Okay, now the derivative of 5x to the fourth power, that would be by power rule of differentiation. We have here 20x cubed plus we have 2y squared, the constant. And by power rule of differentiation, we have here the derivative of x cubed, that is 3x squared, minus we have here 3y, the constant, and then the derivative of 1. Take note, 1 is a constant, and we know that the derivative of a constant is 0. And when we multiply 0 to 3y, that would be still 0. Okay? Now, this expression, we will simplify this further, we have 20x cubed plus 2y squared times 3x squared minus 0. Hence, the partial derivative of z with respect to x will be 20x cubed plus, we have here 6x squared and y squared, right? Let's move on to part B with the partial derivative of z with respect to y. Same process on what we have done earlier. To find the partial derivative of z with respect to y, take note we are now taking the partial derivative with respect to y. Our differential coefficient here is y, meaning to say the x variable will be kept constant, right? Since z is equal to 5x to the fourth power plus 2x cubed y squared minus 3y, we're going to take the partial derivative of the function in terms of y, or with respect to y. In this term, we only have here x variable, okay, which is the constant. We only have the constant. Okay, since we only have here 5x raised to 4, we will be taking the derivative of y here. We have here 1. So we take the derivative of 1 here, then plus 2x cubed, and then the derivative of the differential coefficient, we have y squared, minus 3, the derivative of y. Okay, and when we do the process, we have 5x to the fourth power, and then the derivative of 1. 1 is a constant, and the derivative of a constant is 0. When we multiply 0 to 5x to the fourth power, that is 0. And we have here 2x cubed, and the derivative of y squared is 2y. And we have here minus 3, and then the derivative of y is 1. 1 times 3 is 3. And in this case, we simplify this further. We have a 0 plus 2x cubed times 2y minus 3. That would be the differential or the partial differential of the function is we have the partial derivative of z with respect to y is 4x cubed y minus 3, right? Okay, so that would be all for this morning. Thank you so much.